right, so we are live and I see folks are turning up in the session. Let's give it probably 20-30 seconds. Let's have a little more head count and then we can begin. Perfect. I see a lot of hearts, thumbs up coming in. Folks are already excited for the session that's heading their way, it seems.
Woo!
All right, so yeah, folks are tuning in. Perfect. So meanwhile, we wait for some more folks to join. Guys, let us know where you're all tuning in from. We have Paul from Dallas. I am myself joining in from Delhi, India. Right? So feel free to type that in the chat box. Let us know where you're coming in from. Okay, we have Kamal from Canada, Spurs from India. We have Lisbon, Portugal, Carolyn from Lisbon, and Soumya from Mumbai. A lot of folks are typing in now. Sydney, Chicago, Argentina, Delhi, myself, Germany, Poland. Oh my goodness. So we're having a lot of fans from a lot of different parts of the globe. So having said that, I guess we're on time now. I see a lot of folks into this session. So yeah, hi everyone. I'm Harshit, a product marketer at Lambda Test, and I'll be your host for this session. I expect to inspect performing code inspection on your automation, where we will discuss why code inspections are crucial, how they differ from product software reviews, and share real life insights gained from these investigations by our speaker. Uh, Before we begin, let's quickly take care of a few housekeeping items. This session is being recorded, so at any point of time, if you need to drop off, you can find the full recording of this session in the view schedule button that you will find on the left side of the screen after this session ends. You can also look back on the previous sessions that have happened so far in the day in case you're logging in just now. We also have a dedicated Q&A plan towards the end of this session. So if you have anything as a question while we're presenting, feel free to drop them in the Q&A box. So we'll be taking those up towards the end as well. While we're presenting, you can react to us at any point of time using the emojis towards the bottom of the screen. So make sure you make good use of that. And having said that, join me in welcoming our speaker, Paul Grizzaffi, a senior automation architect at Vaco. Paul's passion lies in providing technology solutions to testing, QE, and QA organizations. With a knack for turning complex concepts into practical solutions, he is your go-to guru for all things automation. Thanks for joining us, Paul. The stage is all yours.
Thank you. I always hear people talk about me and I go, wait, who is that? Is that really me? So anyway, thank you so much for the gracious introduction. Yeah, so my name is Paul Grizzaffi and I am a senior automation architect at Vaco. I spent my career focused on automation and automation adjacent activities. I was director of QA for a while, but the automation thing is the real pull for me. It's where my passion lies. It's where I like enjoying helping testers and helping other professionals just be more effective or more efficient at what they're doing. So I am an advisor to two organizations, one STPCon, which is now folded into 𝐶𝐿TRICON, and for the Advanced Research Center for Software Testing and QA at the University of Texas at Dallas. And I'm equally comfortable talking about test automation and Slayer, Metallica, and Iron Maiden. So if you want to hit me up on those topics, I'm good for you there as well. And if you do want to hit me up, here is my contact info. It's in the slides that I think are probably available for you. If not, you can do a screen grab here, or during the Q&A, I will have that up as well. And that bottom link there is where I blog, so you can check out the hopefully cogent things that I talk about there. All right, done with that stuff. Let's get in, but before we get too far, we have something to settle. We have a level set, and that is that automation is software. So automation development is software development, and we have to treat it as such. If we do not, we're going to run into problems. So what does that mean? All right, we've got software. What do we do with software? Well, I don't know any developers that sit down and go, I'm going to write an if statement. No, there's some sort of plan. There's some sort of goal with the software development. So we have to have a plan. Then we have to do the development and the testing. This applies to automation as well. Wait, why? Because automation software, so we have to make sure that the automation is performing the way we think that it is. Because what are we doing? We're really trusting a computer.
apologies for interrupting. Can you quickly screen share once? I guess the folks
Oh,
are
did
not
it
able to.
follow up? Yes, absolutely. Sorry about that.
Thanks so much for a huge shout out to Ganesh as well. He said that he has always wanted to attend a session from you, especially, and he also pointed out that the screens are, slides are not up yet. So let's have that ready.
Ah, well, that is that's very kind of you. Thank you. Let's see. I am saying that it is to be shared, and I seem to be missing a share button. Hang on just a second while I sort this out. There it is. Hey, there it is. All right, cool.
Perfect.
Sorry about that. So, yes, I will go back just a couple of slides for anyone that wants to take a screen cap of this. I'll give you a couple of seconds and then we'll jump right back on. All right, cool. So y'all will get a chance to see that again later, and it is in the slides. If you have, you should have access to the slides through the conference presenters. All right, cool. So we talked about dev, we talked about test, and what are we doing now? We're support, right? We have to support it. We created something. We have to maintain parity with our systems. We have to store it somewhere.
Paul, I guess there's something wrong with the audio. We're not able to hear you. Yeah, looks like he's going to rework the audio system.
All right, now we good?
Yeah, we're good now. Probably you can take the
All
last
right.
pointer again. I guess folks missed out on that one. Yeah.
I'm sure it doesn't sound as good as it did before, but at least you can hear it. So there we go. I'm gonna have to get a new microphone, I guess. All right. So yes, so we have to support it. We have to store it somewhere, right? It's Git, GitHub, it's ALM, it's somewhere. We have to deploy it. We have to get it to where it's going to run. It's awesome that the automation runs on your desktop, but that's probably not where you want your runs of record. You want it to be stored somewhere that you can pull it into some continuous testing, continuous deployment pipeline. How are we going to get it out there? We got to do that too. And then what do we got to do? We got to version it. We need to know the difference between, hey, we need to run in what's in the dev environment versus what's in the QA environment versus what's in the pilot environment. We have to be able to manage all of that stuff. But the other thing we need to be able to do is inspect the code. We need to look at the code and see that it's fit for purpose. And that's what we're going to be talking about today. So we talk about a code inspection. It's also called a code review. I call it a code inspection because that's how I learned it first way back in the 90s, but it also fit with the pun up at the beginning with our Inspector Clouseau there. So again, you may hear this called code review. I will use the terms interchangeably throughout this particular presentation. And really, it's a systematic review of the code. Sometimes it's a deep dive, sometimes it's more of a skim. But the idea is, just like when you're debugging and you're stuck and you go, man, can somebody come and look at this with me? It's the same idea, right? It's the same idea as an editor for an article or a book. It's a second or third or fourth or whatever set of eyes to look at the code and say, yes, you know what? I see what you were seeing, but I'm seeing these other things too. Because we're looking for current problems or potential problems. And we'll go through some of what those potential and current problems might be a little later in the talk. And sometimes, like I said, it could be formal inspections where, okay, I got a PR and now I spent, I blocked off an hour and I'm going to go line by line. I took a bunch of notes and made a bunch of scribbles in there. Or sometimes, the review could be, hey, you know what? I changed a few lines of code here. Can we do a quick screen share and I'll walk you through it? Each of those would potentially count as an inspection or a review, as long as it's appropriate and provides the right risk profile for whatever code changes you're making. So why do it? Why do we even bother with this, quote, extra work of reviewing code? Well, first of all, mainly we're looking for errors. Is there something wrong with the code that we didn't catch in testing, that we didn't catch when we looked at it ourselves? But somebody else having a look at it will go, hey, look, you're off by one there. Maintenance. It looks totally reasonable to us because we just wrote it, right? It's all in our head. It's right there. But if another person who is adept in coding comes and looks at it and goes, yeah, man, you know what? When we change the product, we're gonna have to rewrite this area completely. Is there a way that we can write it once up front where it's more maintainable? And looking at risks, this set of code is going to work very well with what we have today. If our user base increases by 10K, are we at risk of being non-performant, of having bugs, of having crashes? And sometimes just classification. Hey, this particular test script, that needs to go in our smoke suite, or it needs to go in our regression suite, or it touches these 5 different parts of the system. So we need to add an associated tag so that when we update those parts of the system, we can run those scripts, etc. And much is made of the cross-training, and I think probably a little too much is made of cross-training, but there's not zero value in it. Hey, I'm a new person, or I'm new to this part of the code. Having me perform the code review or be sort of second chair on the code review can be beneficial to me, but that's not really the way to learn the code, but it certainly can be helpful. So before we go, we don't want to forget that automation is software, and we're going to need to treat it that way and inspect it that way as well. So how do we approach this whole review inspection thing? Well, first we inspect all code, every line of code, most of the time, right? Some stuff there we might say the risk is so low for the change that was made here. It's not worth the effort to go through anything even smelling like a formal review. Maybe you email me the code snippet. Maybe we just say, that's the person that knows the most about that code. If that person can't make that one line fix or that one little tweak, then we're all probably in a bigger problem than that. But in general, you want to inspect all the code, some second set of eyes. And think about it from a stewardship standpoint. I worked with a guy once who said that the test organization, the QA organization, whatever you're called, you don't own quality. You're not even really responsible for quality, but you are the stewards of quality. Your job, our job, is to help everyone else, including ourselves, but the team as a whole unit, do things with quality in mind and make decisions such that we are providing an appropriately tolerable risk profile for the decision makers that do decide, yes, let's release this, no, let's not release this, more testing, less testing, etc. And involve the team. And I'm going to give you some examples of what I mean by that here in a couple of slides, but everyone is a candidate to have a look at the code. The code should not be secret. And I mean that from product code and app code, but also from the test automation code. It's not like, hey, I wrote it and it's mine. Anybody should be able to have a view of it and have an opinion on it. Now, certain people's opinions will be more informed than others just based on their experience, but it doesn't mean the less informed opinions aren't valuable. There may be just some overweighing or some aspects that are unknown to the less informed might outweigh some of the concerns or thoughts that they have. And involve the users. This is an advantage we have with test automation. We almost always have very direct contact with the users, especially if we're an automation team creating automation on behalf of testers who are doing other jobs, right? We're not the testers, we're the button clickers, right? That automate the things that the testers find useful or valuable to help them be more effective or more efficient. We have to involve the users, right? Get them involved to look at what it is that we have going on and say, yes, I trust that, I value that, or nah, man, you missed the mark on that one. Let's tweak that a little bit. All right, so yes, the testers need to participate. But wait, I'm a tester, I'm not a programmer. Damn it, Jim, I'm a doctor, not a software engineer. That's fine. That's fine. There's nothing wrong with that. Different people have different skill sets, but you still can participate in a review, because when I talk about review and inspection, I'm pretty broad about what I'm expecting. right? Run it. Does it work? If you watch, especially we're talking about some sort of GUI-based test like browser or a thick client or a mobile app or something, watch it. Does it do what you would have done in that case? Did it catch things you would have caught in that case? If so, all right, right on, cool. It works sufficiently that I can trust it to do some sliver of my job for me. And do I understand it? If I look at the code, is it just completely alien to me? That might be okay, depending on what your background is with code and your comfort level with code is. But if you can't look at it and understand, okay, this group of statements kind of looks like it's sending this message, or it kind of looks like it's validating this value, it might be hard for you to understand. And the less you understand, the harder it is to trust it. Now, it may be that you spend more time checking to see if it works and you build your trust that way. There's no wrong answer to this other than doing things non-deliberately, right? Anything you do deliberately and say, I'm good with this because I have checked it to my satisfaction, that's fine. You're right or you're wrong, but you won't know until later. But you made a responsible choice and a responsible decision. Can I support it? A lot of organizations, I wrote a blog about this, there are different types of level of interaction with test automation. Perhaps you don't have the particular acumen to create that test script from scratch. However, you know enough about code that you could make some minor changes to keep parity with the system. Hey, you know what? The capitalization on that text changed. Can I, as a non-primary coder, go in, do I have the acumen to go and make that change? And if I do I understand how to make it? And at the core, as a tester, do I trust it? Do I trust it to do a portion of my job such that I don't have to redo that because, yeah, the automation passed, but I feel better if I do it as well. Because at that point, you've wasted something. You've either wasted all the effort that went into the automation, or you wasted your effort time after time, double checking what the automation did. There's something to be said for spot checking the successes in the automation, right? Because we get failures. Everybody, oh, we have failures. We got to go figure it out. Sometimes you should check out the stuff that's passing as well, simply because it may be passing, but maybe it shouldn't have passed. But ultimately, you have to trust the mechanization, the release of that particular part of your job to a machine that you can't really go and interrogate like your buddy or your friend and say, hey, Jane, did you test this? Did you test it this way? Did you check for this? It's a different kind of review and different kind of inspection that you do from programming and from an automation standpoint. But hey, programmers need to participate as well. At the very least, if I'm an automation person and I wrote some code, I want another developer. I like automation people to come in and have a look, but somebody that has some programming acumen and at least a little bit of domain awareness to come and have a look. Be my second set of eyes and say, is it supportable? Is it maintainable? Did I miss something? Am I off by one? I keep talking about off by one, and we're going to see that a couple of times in the examples in just a few minutes here. So having programmers participate from a correctness standpoint, very valuable. But also, hey, to follow the coding standards. We have this coding standards document. If you miss something here, and standards are important or they're not. I think they're important, but I think correct, readable, supportable code outweighs standards in some cases. And those have to be, again, judiciously applied. Are there any performance issues? You know, there's a thought that says, okay, you can't really judge performance issues until you run your code through some sort of performance checker, right? Some optimizer, something that says, hey, you're going to get stuck here. Yes. However, there are, for very experienced developers, there are some things where they say, oh, hey, you're using that data structure here. In my experience, that's fine until you get about 10 or 15,000 entries in that list. At that point, your performance is going to degrade. you might consider this other data structure instead. And then coding gotchas, stuff like, yeah, you know what, that's going to work until this other kind of thing happens, right? So performance issues would be a subset of that. But little gotchas on, yeah, that's fine until somebody puts in some punctuation. True story. My wife is a PA in a medical practice, and they got a release years and years ago of their EMR system, where if they added any punctuation in any of the text fields, the whole thing seized up and it crashed. And then they had to get the company to do a reset. Can you imagine that? Number one, who tested, right? But also the gotchas from a code inspection may have caught that even outside of the more traditional dynamic software testing. All right, so I touched on some of these things, but here's some others for you as well. So what do we look for when we're doing a code inspection? The two major categories, there's the static analysis and the dynamic analysis. And the static analysis is, hey, I'm looking at the code just as a, have I dropped audio again? Can anyone confirm that they can hear? Okay, cool. Someone can hear me. Awesome. All right. I just saw somebody said that they could not hear. So errors or likely errors. Hey, that line of code right there is a bug in it. Or, you know what, that doesn't look right. Maybe add another test or check this thing out to make sure that it's right. Adherence to coding standards. Comments. I'm a heretic. I fully support and believe in self-documenting code. All right. Fully believe that. However, self-documenting code is great at telling you what something does. It is not good at telling you why that implementation choice was made, or just as importantly, and maybe more importantly, why a less intuitive implementation choice was made. For example, I'm going through a list backwards. All right, cool. I can see that. You can even write the method name, go through this list backwards. Cool. Why? Why are you going through it backwards? That's important. Why aren't you going through it forward? Oh, because it's because we know that most of the time the data is toward the end of the list because of how we're building the list, and we're looking at 500,000 entries in this list, so we're going to try and make it as performant as possible. That's what you put in the comment. Also, appropriately human readable. I will take 10 lines of readable code over one line of cryptic junk 100% of the time, unless there's some other sort of performance or scaling or other types of issues or items there. And warnings. You should have 0 warnings coming out of your code. 0, not statistically 0, 0. Now, that said, sometimes you need to do things that you say, okay, I understand the warning. In this case, I need to do this, and I'm not going to run into the issue that the warning is telling me. Cool. Most, if not all, programming languages have some sort of pragmas or something that you can wrap that line of code in and say, ignore this warning right here, but only right here. Give me the warnings other times. Warnings are indications of possible problems. So if your code has warnings, you should probably go and figure out why and either address the warning or intentionally wrap that code to say, okay, ignore that warning in this particular spot. So that's the static stuff. Oh, before we get to the dynamic stuff, on coding standards, we'll talk a little more about it in a few minutes. I know I keep punting things down, but I like to start with high and dig. But anything that you can programmatically check with coding standards, do it programmatically. Use some software to do it. It takes the feelings out, takes the politics out, takes a lot of things out. And you know that if it's gone through a successful build, and as part of your build, you have this sort of coding standard check in there, then before anyone even reviews the code with any sort of formality, you don't have to worry about capitalization and camel case versus Pascal case and underscores and all that stuff. That tool made that decision for you already. So you can focus on the things that the tool either can't catch, or hopefully focus on the things that are going to be programmatically in behavior problems in the software. So dynamic analysis it's more like testing, right? But we're testing with a more narrow focus here about just the code quality as opposed to the application quality. So as I talked about before, watch it run. Run it yourself. It might be important that you run it yourself. And then time it. Hey, you know what? That sure seems to run slower in automation than when I do it myself. That might be a problem. It might not be a problem, but it's something to be investigated. And make it fail. Make it fail for two reasons. One, I'm going to change something that this should fail. And that test case, that test script had better fail. If it doesn't, then we have a problem in the test script. Something that we expected to be checked is not being checked. So we may have a trust issue there if we don't get that resolved. But also when we make it fail, or the logs, the reports, all of those things, do they tell me what happened and then what the failure is, such that I can at least do some rudimentary triage and start forming opinions of where to look next from those logs? Or is it all gibberish and hard to go through? If it's really hard to go through, your time to feedback, your time to fix, it's all going to go up because there's going to be more effort involved in digging through all the dreck that just came out at you. So tools. I mentioned having tools to do some of this stuff for us. Fortunately, somebody, and I didn't bother to put their name here. Sorry, person. This is a good list. It's a list of awesome static analysis tools for multiple different languages. So you can go out there, you can pick your language, you can see what tools you might be able to use out there. I mean, some of the stuff's pretty standard. A lot of us know about, like Sonar and StyleCop and Check Style. And I don't know if Clockwork is still a thing, but I used to have a list here, and then I found this list. And then things change and companies buy stuff and rename it. So I figured just point you to the list. That's the best way to send you out there. But this is the but section. So but I have unit tests to check all my things for me. So why should I do a code review? Okay, cool. Happy that you have unit tests for your automation. Wait, we're testing the automation and we're testing the tests and we're automating the automation? Yeah, and at certain times, that is certainly appropriate. But dirty secret for you, that stuff you wrote in PyUnit or RSpec or whatever, that's code too. And there are bugs in there too. So you should review your unit tests, maybe not with the same level of scrutiny as your core automation code. Maybe, it depends. Are you writing a website for trading emails? Maybe it's not a big deal. Or you making a website to track organ donations? You might want to spend a little more time on that one, right? You might want to put a little more effort into checking and testing around life-critical and near life-critical systems. But we do pair programming or mob programming or group programming. Okay, this one's a little more interesting. So let's just talk about pair programming first. Pair programming in the strictest sense is somebody's driving, somebody's giving instructions, and you're both at the same time providing input and checking for issues and bugs and stuff. You may decide that we don't need an additional set of eyes for that. You might say, because of what we're doing, we're good here. Again, this is where we start having the discussions of risk and being appropriate. Life-critical systems, you might want another set of eyes on there. Non-life-critical systems, and it's not your bread and butter. Oh, hey, this is our e-commerce part. We probably do want to have somebody else there. Oh, this is our user profile configuration with modes and themes and stuff. Maybe the pair program is good enough. And I know All the stuff I said here is still kind of far-fetched, but automation is software, so we must treat it as such. And as such, it will have bugs. So really, what are we looking for? We're looking for issues, right? Potential and actual. So now we're going to start looking at, all right, what kind of bugs can we catch during code review? Certainly any kind of bug, but the ones that are nagging, that you spend a bunch of time and at the end you go, oh man, dang it, that was careless. I fat fingered that, or dang it, if somebody else could have looked at it. So here we have the Boolean assignment bug. Now, a lot of the more modern languages, you can't do this. This is an error. But look here. This is not actually a conditional. It's an assignment in a conditional. And most notably, C# and C allow you to do this, or at least it did a couple of years ago when I first wrote these examples. I think you may get warnings now, but it still will let you do that. This is something that's very easy to miss. And what happens is that in this case, looking at this code will always go into the if. Why? Because the assignment always is going to return non-zero. That's just the way the algorithm and the way the code works. So you're never going to get into that else. I think if they're both 0, you might get into the else, but in general, the code will not behave the way you want. And you say, wait, static analysis tools can catch that. You're right. Stick with me here, though. The off by 1 that I've been talking about. All right, so off by 1, what do we mean? That means we went through a loop, or we checked a condition that was off by 1. Look at this. If we're going to go through this list and we have to go all the way to the end, we're going to get some sort of array out of bounds exception or a segmentation violation or something, because we will try and access the length, right? If we get 10 elements, we're going to try and get the array index of 10 because of the way this is implemented. We want to go 0 to 9 typically, right? That's the sort of the idiom for most programming languages. Hey, static analysis tools can catch this for us too, right? Absolutely. Wait, AI can catch this. I can shove this in the ChatGPT and it's going to catch it for me. Will it? We'll get to that in a minute too. Now we start getting into places where static analysis isn't going to be quite as useful. So when we talk about logs and errors, they are our bread and butter for understanding what happened for an automation run. An automation run on your desktop is great for debugging automation, for reproducing issues, but you don't want to tie up your desktop for your typical smoke test runs and regression test runs. You got other work to do, and we have other machines to do that. Unattended execution. And in unattended execution, we need the logs, the breadcrumbs to tell us what's going on. So that first assert certainly will catch an issue, and it's going to give us assert is true failed. Accurate, not terribly helpful. The second one, a little more helpful. It says expected a 1, but got a 2, but we don't know what it was checking at that point. We'll have to go dig in the code to find that out. And if we're not really code savvy, we're going to have issues there. Much better here, an unattended execution run. Here we can say, well, I was expecting value 1 to be this, but value 2 was that. But in order to make sure that's all appropriate, we have to review it, because it's much easier to make a mistake that way. And then we get to the repeated code. Very familiar login flow we have here. We have this in 5,000 of our test scripts because we can't do anything interesting in our app until we log in. I noticed that in a few spots. Why don't we pull that into some common, more supportable area so that we can just put it one spot and be done with it? But code analysis tools are going to find repeated code too. They sure are, but they're not going to help you with naming it appropriately. So again, this just in. automation software, and I'm going a little faster because I'm checking my time here, and we're going to be done pretty soon, and I want to take questions. But AI is going to do all this stuff for us. It's going to create code for us. It's going to check our code for us. Will it though? Let's see. All right, so here, is there a bug in this code? Let's look at the code. There might be a bug here. I'm going to go through this code 11 times. And hey, ChatGPT said you're going to go through the code 11 times. But it also said there's no bug. But look what I named it. I said I want to go through the code 10 times, but it's going to go through it 11 times. Is there really no bug here? All right, maybe we gave it too hard of a problem. So let's level set. Let's tell ChatGPT, hey, now I want to go through this 11 times. And it says, hey, there's no bug here. It's going to go through 11 times, and it explains what it's going to do. All right, awesome, sweet. Now let's try that bug again. Same code. Wait, now it gives me a different answer. All right, so we have a consistency concern here, but it says, oh, hey, there is a bug, and it's going to run 11 times instead of 10. And then it gives me a fix. Is that the right fix? And I say, hey, how do we know if the function name's wrong or if the condition's wrong? It decides for you. It decides for you that the condition is wrong. How does it know? So these AI tools are awesome as assistants, but you can't completely trust them the same way you can't trust like a brand new hire or an intern to do some more sophisticated work for you. They just don't have the knowledge for that yet. So careful with what you trust these things to do for you. So we also have to plan for inspections, right? Most of us work in some sort of agile or ticket-based environment or culture or process. So we have to have the task for the inspection. Wait, 4 people are going to inspect the code? Well, then you better have 4 tasks, 1 for each of them. And then a task for rework of the code. Well, why review it if you're not going to rework it? So have a task for that. Then a task for retest, because after you rework the code, then you're probably going to need to retest the code, unless you bake all those things in together. And then possibly a task for re-review. If you're touching a sensitive part of the code or you've made a sweeping change, you might want to have someone else re-review your changes. But ultimately, be kind, right? As no assessment says, we don't want to spend our time dealing with the security of our indentation, right? Code reviews are about helping the code be better so we have a better experience as all the users, right? Our customers, our clients, ourselves, our future selves are just going to have a better time. And then I have a long story here, and we're not going to get with we don't have time for the long story, but perhaps start with what everybody else is doing. If you're using a language where you can Google what is a standard coding set of rules for C# or Java or whatever, I bet you can find one by Sun or Oracle or Microsoft that says, start with this. And then just a few minutes for questions, but some kind of inspection is usually valuable. But you got to let the business value drive the inspection, whether it's a walkthrough or pair programming or a deep intensive inspection. Use the tools where appropriate and just make it a positive experience. And before I let you go, automation development, software development, treat it that way and inspect your code. So now I think we have about 5 or 6 minutes for questions. So I'll turn it back over to Mr. Moderator.
Yes, thank you so much for that session. And we have quite a long list of questions here. So to begin with, I'll
Awesome.
start showing them on the stage as well. Right. So how can the entry and exit criteria be best defined in a code inspection?
So I'm going to make a leap here and say, when you say entry criteria, that means the automated part of the steps that you do before the actual thing you would call the test. And then the exit criteria would be the, hey, I'm tearing down things I set up and stuff like that. You're going to best to do it. Man, best is so relative. It's really most appropriate. Is it Usually if it's a repeated set of steps or something that is parameterizable, I would put it in a separate method or routine or function that you can pass parameters to, or it can read information out of a database or some sort of a data store to get that set up. If we're talking more about entry and exit criteria for, hey, I'm ready for testing and I'm done with testing, oh, there are probably even more even more approaches than that. And without additional context, you call me ChatGPT. I can give you answers and they might make no sense. So I'm gonna defer on that one unless we get more context.
So you also talked about being kind. At the end of the day, it's about improving quality. So here's a good question from Josh. He asked, what's the best way to inform a team member that their code isn't up to par?
So there are a couple of things here. Number one, use the analysis tools as best as possible. Let them be the bad guy. Let them be the villain where you can. Now, if we're talking about more of a dynamic analysis or static analysis where the tools just can't get that part of the job done, humanize it, empathize, put yourself in that other person's position and say, okay, how would I like to receive this input? Now, that's not a foolproof answer because everybody likes to receive and give feedback different ways. But as soon as you start putting a human face on it and saying, instead of your code sucks, you're saying, hey, I see some opportunities where we can not have some maintenance later, or, ooh, I think I may have found a bug. Could you walk me through it? And then help them come to the realization themselves that either there's an issue there, or maybe you come to the realization that says, oops, I misread that, or I misunderstood what was going on. I'm gonna erase my comment on that. Putting a human face on it is probably the best thing I can ask you to do outside of letting the machines handle the really nasty bits.
Right. We also have this question from Mehak, which talks about, can you suggest any platform that can help practice improve code quality?
So when we say platform, if we're talking about a tool, yeah, I would say a lot of the static analysis tools can help. And what they'll do is they'll give you a really binary answer. Yes, I found no issues, or I found these 12 issues, you go and fix them. And then over time, you'll say, okay, wait, I'm going to change the way I code because I don't want to have to deal with that thing telling me to go fix them. If we're talking about platforms from like a training or educational platform, there's all kinds of stuff out there that will teach you good coding. And a lot of the stuff is going to be consistent and I hate to use the term best practices, but I'll say well-established practices that are good in most cases. I would go to some sort of reputable site to start looking at that stuff, like Pluralsight or Udemy, or if you're looking strictly at test automation, things from Test Automation University are pretty high quality and they can help you there as well. And Test Automation University is free.
There's probably one last question that we can take. It's
sure.
How do you strike a balance between code review and business alignment during code inspection for automation, ensuring scripts align with technical standards and strategic goals?
This sounds like a loaded question. Somebody's having a specific problem they're trying to get an answer to here. So it's all about, I mean, if you think about testing, never mind automation, not automation, experiential or manual, automated, whatever. Testing in general, in most cases, should be about delivering information to appropriate decision makers about things you have found out about an application, things you would like to have found out about an application but didn't have time, and then explaining some of the problems that could manifest themselves or have manifested themselves during what you have found or what you have not been able to get to, so that the decision makers can say, this software, we believe, with an appropriate level of risk, is performant enough to release today, or it is not. So if we look at all that together, is it more important to have your comments correct than have the code perform correctly? No, it's not. But wow, that comment thing's going to bite you in the bottom sooner than later. So they're both important. But if I have to pick one, obviously I'm going to go with, does it behave correctly? So you need to figure out what your risk profile is, what your maintenance profile is. Yep, I can get it out the door, but boy, it's going to cost us 3x in maintenance 2 months from now. That's a business decision that testers and the QA team can't make on their own. They can only inform the decision makers about what they found.
Right, and I did said that that was the last question, but here's a quick nod that is needed from you to 𝐏𝐴𝐵𝐈O. So at the heat of everything that you said tonight is the skill possessed at the human at the center of it. Let's not lose focus on that, as it is the most important part of it. Do you agree, Paul?
Yes, because the way I look at things is a company or an organization has goals. There's a strategy and there are goals. Every line of code that's written should be in direct or indirect support of those goals. Everything that we test as testers should be in support of giving enough information to the stakeholders to say, can we deliver to those goals with a tolerable risk? And every line of code that we write for automation is in direct support of helping testers do that, do their job. So it's a loaded question. And I'm going to go with, I think the answer is yes, if I understood the question correctly.
Yeah, a lot of loaded
I'm good with the
questions.
weasel words too.
So a lot of loaded questions that we faced in this round. Quite an interesting session, of course. For any question that was unattended so far, you can address them over the Lambda test community. We'll be opening up a thread, and Paul could probably have a look at that as well and address it over there. And our experts from Lambda would also be having a look. You can also catch up with Paul in Fluid Space in case you haven't checked what that is. Do give him a hand. See, Paul, if you could just stroll around, have a look, maybe connect with these folks who had these loaded questions pointed towards you and get to know them better on that front. At the end of the day, I would just like to thank you, Paul, from Paul to Paul. We were roasted by that in the chat as well by somebody, but yes, thank you so much for being part of the TestMu and sharing your practical insights in this session. And a big thank you for everybody who has joined us in. In case you joined in the middle of the session, you can find the entire recording. You just have to click on the view schedule button that you find on the left side to the top of the screen, and you can watch the entire session once we end this from this side. So happy testing and have a great day. Thank you so much. Bye-bye.
Thank you.